Hello, everyone, and welcome to today's SANS webcast. What's in your financial services software? Sponsored by Snyk. My name is Carol Auth of SANS, and I will be moderating today's webcast. Today's featured speaker is Alyssa Miller, Application Security Advocate at Snyk. If during the webcast you have any questions for our presenter, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to turn the webcast over to Alyssa.
All right, well, thank you very much. And hello, everybody. Good afternoon, good morning, good evening. I guess it depends on where you're at in the world, but I'm happy that you're here to spend a little time with us today. We're going to talk a lot about a particular challenge in financial services and indeed across the entire tech industry, but something that's really near and dear to my heart. And that's kind of this whole idea of software supply chain security, and specifically, how do we get to the point of being able to really understand what's in our software? So I know I got a little bit of an introduction there. I'll give you a little bit more just to tell you a little bit about me for those of you that I've not met before. Again, my name is Alyssa Miller, and I'm an application security advocate for Snyk. Honestly, I've been a hacker all my life since very early on. I mean, at 12 years old, I bought my own computer and definitely got into some of my first hacks way back then. We're talking, I'll kind of date myself, but we're talking late 80s that I really got into the world of hacking computers and so forth. But that really wasn't the career I went after. Certainly back in those days, hacking wasn't really a career, but I did get into ultimately software development, a roundabout way through a pre-med program and whatever. But I was a software developer for about 9 years working in the financial services industry. I worked for what is now one of the, I think, the world's largest financial technologies organizations. We were pretty close to it at the time. And I developed a lot of different software around their electronic payment and home banking platforms before I moved into their security team. And within their security team, I was responsible for managing not only their security testing team and performing penetration tests myself, but also managing their entire vulnerability management program. And so that career lasted 15 years before I decided I'd seen enough of financial services. I was going to get into consulting. And honestly, most of the consulting work I did was back in financial services anyway. So my background, the reason to go through all this is just so you understand where I'm coming from and the world that I've seen and how that relates to what you see and why we're speaking specifically in terms of financial services software today. So with that, I want to kind of dive right in. So one of the key struggles when we think about software supply chain security is this idea of just knowing what's in our software. And across industries, we're seeing this challenge show up. This particular headline regarding medical devices. So we see it in the medical field where the FDA issues the safety communication, and manufacturers around the world couldn't tell the FDA whether or not they had this particular piece of open source software in their firmware. These are challenges that are tough, but it extends beyond that. How many of you remember Heartbleed? How many of you were around for that and remember scrambling through your networks trying to figure out what systems you had, where they existed that might be vulnerable because of Heartbleed, and figuring out which ones had been patched, which ones needed patches, which ones didn't have patches available. All of that, just trying to sift through that environment. These are the challenges that we've worked through for generations in the IT industry and total, and for sure in the financial services industry. But it continues to hit home. And in 2017, we saw yet another example of this that was very public. I mean, it seems funny that this was that long ago. It doesn't seem that long ago, but the Equifax breach. And we're still feeling the ramifications of it. But it all started with vulnerable open source software that existed in their environment that, we don't know the whole story, but it seems like they probably had trouble identifying that it was there, just given the fact of when these advisories came out about this vulnerability and the fact that they remained present in the Equifax environment for so long after. So this is the challenge, and it's something that I know I talk to executives in the financial space all the time, and it ends up being one of the first questions I'm always asked. What do we do about this idea of software supply chains? How do we secure that? How do we make sure that the components, the software, the third-party elements that we're dependent on as an organization that are part of our critical systems, those business critical financial platforms that we need every day to service our customers, how do we make sure that that is free of software vulnerabilities? And indeed, the challenges are tough and they continue to grow. So I've heard some people within the industry pontificate about how they've removed all open source. They don't allow their developers to use open source software in their environments anymore. And it sounds like a great idea, but the reality is that's not the way modern development works. When we look at modern development, here's a Java application. So this is a 80 lines of code Java application. It's 3 Java files. It's tiny. Back when I was a software developer, if I wrote an application that was 100,000 lines of code, I wrote those 100,000 lines of code. But that's not the way it works anymore. This 80 lines of Java code, which includes 3 files, well, one of those files defines all of the dependencies that this Java application has. And where do those dependencies come from? They come from the open source market. And indeed, here we see 7 specific direct dependencies that our application is calling off the open source market. So you look at this and you say, well, that's great. Okay, every ecosystem that my developers are developing in, I know right where to go to find these dependencies. We can discover this easily. We should be able to build a list quite simply and no problem, right? Well, the challenge is each one of these dependencies that exists inside that code, yeah, they've got their own dependencies. So in the case of this particular 80-line Java application, those 7 direct dependencies turned into 59 additional transitive or indirect dependencies. So those are 59 dependencies that you wouldn't know about just by simply looking at your code. And this is where we start to see things like old struts frameworks that still exist in our software that we don't even know about. The other result of this is those 80 lines of code turn into 713,000 lines of code. So if I'm thinking about SaaS tools and, my SaaS tools are going to keep me safe. Well, one, a lot of SaaS tools still aren't walking that dependency tree and they're not getting past, a lot of them don't even look past your own code. Some of them have options to look at your dependencies and at least do some work, but 713,000 lines of code. Think about how long and what the licensing costs are on that. And that's from an 80-line Java application. When we're looking at financial services applications, we're looking at things that are far more complex than that. We're talking about much larger applications where our developers have probably written a couple 100,000 lines of code. And now we see on order of 100, 200, 500, we've seen some applications in the Snyk database that have over 2,000 indirect dependencies. Imagine what the line count is on that. You're not going to scan that all with a SaaS tool, and it just doesn't work that way. Now, those indirect dependencies are rough. And indeed, as we look at projects that we've scanned using the Snyk tool in particular, what we see is that in certain ecosystems in particular, those indirect dependencies are the ones that are responsible for the bulk of the vulnerabilities in those applications. You can see here Maven Central, which are your Java applications, NPM, which is your JavaScript if you're got developers developing in Node.js. You see Ruby gems here as well. And of course, on the better side, we see PHP and Python. Yeah, that's great. We see fewer numbers of vulnerabilities coming from the indirect dependencies, but they still exist. And as we all know, we talk about it all the time in security. It only takes that one vulnerability that is exploitable that an attacker is going to leverage against us. So this is tough. How do we start to wrap our hands around this? Well, I wish it stopped with just the application code. But the fact of the matter is there are other challenges at play here because we've moved in this whole new direction. We started off with digital transformation and everything was becoming more digital. Then this little thing popped up we call the cloud. And we've heard in the industry, there's been plenty of headlines about cloud vulnerabilities and cloud breaches where things like S3 buckets are being exposed. But what does cloud transformation mean to our developers? When we look at it, we've got our developers now creating the very infrastructure on which their applications are going to run. So now, and I love this quote from Kelsey Hightower, it's one of my favorite tweets I think ever. We're not just expecting these developers to understand their development environments. They now need to understand Linux operating systems. They need to understand Kubernetes and how that orchestration is going to build their containers. So of course, doing that, you need to understand Docker as well. And all of these other technologies that we collectively refer to today as cloud native technologies, these are all the things that we're expecting our developers to be able to deal with. And so we think about containers in particular. So containers have, since they started, security people jumped all over the idea of containers. We could create these ephemeral container environments where we have these short-lived buckets that run our code and then they disappear and they're gone. And so if one gets compromised, oh, it'll only be there for a few moments and it will go away. Well, that would be great if those exploits weren't reproducible and scriptable. That would be great if there weren't attacks directly against the containers themselves. That would be great if attackers weren't using those containers to pivot to other areas of our network. But the fact of the matter is that's exactly what they're doing. And so the contents, the images on which we build those containers become crucial to the security of our environments. And those containers, more often than not, are built on open source based images that come from Docker Hub. So what do we do about this? Well, I read a blog not too long ago, actually, and I won't name and shame, but I will share that this blog was from somebody who had been asked how to secure container images. Somebody was building an application and they wanted to know, what do I do to make sure my container images are secure? And the person who wrote this blog told them, well, go to Docker Hub and pull the official image and use that official image as your base image when you write your Docker file. It's a great idea. Hey, Docker Hub has all these official images. They're all secure, right? Well, in our State of Open Source Security report, which we published in June, we did a lot of research into different vulnerabilities. You've seen some of the graphs already. This is another one. And these were the top 10 most popular base images from Docker Hub. So I went out and I just pulled the top 10 most popular. I pulled their latest tag, which means it's going to give me whatever that, whoever authored that container or whoever built that container, whatever they specify as their latest image, it's going to pull that one. And as we look at those container images, you see here the number of vulnerabilities that exist. You see here a specific outlier. We've got Node on the far left there. That's your Node container for running Node.js apps. And we see over 600 vulnerabilities. 15 of these were critical vulnerabilities in the operating system. It doesn't get better. I mean, it does in terms of numbers, but 83 in Nginx, 78 in your Postgres database image. Those are not small numbers. They're dwarfed by the 642 that exist in Node, but they're still not small numbers. So understanding the open source nature of containers, how we build these base images, and which base images are a part of our container images is crucial. What I can share with you as well is that when we look at, say, that node image, just changing the base image from node latest to node buster slim, so shrinking it down and not having all of the libraries that are included in that large dash latest image, reduce these vulnerabilities by 90%. So just knowing which base image is being defined for our software that we're using in our container, being able to gain visibility into that across our DevOps pipeline or across whatever, if it's an agile development cycle, whatever it is that we're using, but being able to gain intelligence and visibility into those images is so crucial, because we can change the landscape and the threats to our environment so immensely just by being able to adjust those base images. But the fact of the matter is, as crucial as it is for us to understand our dependencies and to understand how we're using open source software, I'll go back to that report one more time. We asked in our survey, how are you tracking your open source dependencies? And what we found, I wish I could say it was shocking. It's not. It's definitely alarming. You see here that 28% were confident. A little more than 1 in 4 said, yeah, we have good visibility. We're confident we have good visibility into all our dependencies. But then you see another third that only see their direct dependencies. So they understand that landscape, but think again, if they're building, JavaScript is so prevalent in the financial services market in particular. Java applications, we saw how much impact those indirect dependencies have on the security and the vulnerability landscape of those Java applications. And yet here we are, a third of these organizations aren't able to even see within those indirect dependencies to know what's in their software, to know what vulnerabilities exist there. And of course, the scariest part, the 39% who don't have good controls or don't even know if they have controls around this, which experience would say probably means they don't. 39%. That's over a third of organizations that have no visibility into the areas where over 80% of their vulnerabilities are coming from in their software. This is a concern. This is a challenge. This is why software supply chain security is so crucial. But we're not there. This is why we need to talk about this. So how do we get there? Well, we're going to get into that, but there's another challenge we haven't talked about yet. I've talked to you a lot about security vulnerabilities. I've talked to you about the vulnerabilities that exist in your Docker images. But in financial services, we have other issues too. We need to be aware of the licensing landscape that our software introduces to our environment. And indeed, when we're pulling software from the open source community in particular, and we're pulling those packages and making them part of our software, what do those licenses actually mean? Are we in compliance? Are we at risk because we're violating the licenses that are a part of the open source community? Yeah, it's open source. We understand it. We can use it. But open source doesn't mean you get to use it however you want, wherever you want. Licenses are defined across the open source community, and they vary from package to package. So how do we know that we're in compliance? How do we know that there aren't components to that license agreement for that particular package that we're leveraging that are too restrictive for how we're using it? Do they say it can't be used for commercial use? That could already be a problem for us. Do they say that attribution has to be supplied? Sometimes they do. On the other side, what about overly permissive conditions? What about those conditions that say if you modify or use this software, all of the software that you build with it now becomes part of the open source community? Do we really want our electronic payment platforms, our card processing platforms to now be suddenly subject to exposure through the open source community? We want to give up all that intellectual property, all of that code that we've spent millions of dollars developing and researching and building and refining and continuing to maintain? In some cases, sure. And there's a lot of great financial institutions out there, some of the biggest names in the industry, who continue to contribute to the open source community every day. But there are those times where there is software that we don't want to contribute to the world at large. And so we need to understand what those license conditions are there as well. And then finally, there are those packages that just don't define a license. And what does that mean for us? We're using this package. They haven't defined a specific license for how we can use their package because it's in the open source community. It's assumed that it can just be used as we see fit. But what if that changes down the road? What if any of these licenses change down the road? We need to be able to understand that. We need to be able to visualize that. We need to know what's in our software and where it exists in all of the software that we've created or that we use. Could be third party. So any software that we're using throughout our environment. So how do we do that? This is where we start to talk about the software bill of materials, or the SBOM. Many of you are probably familiar with this concept. Some of you may not. Those of you who are not familiar with it, maybe you've heard of just a bill of materials before, and you understand what that is. When we talk software bill of materials, we're talking about getting that handle on our software supply chain. Understanding for every piece of software that we build, for every piece of software that we purchase, for every piece of software that is in use in our daily environment, what is that software made of? What is that bill of materials that went into building that software? This is how we identify when we have those vulnerable packages, those open source packages, those open source components, those libraries, things that could potentially introduce vulnerabilities into our ecosystem within our environment and could spell trouble for us as an organization. Building the SBOM is how we begin to take control of that and visualize it so that the next time there's a heartbleed, we're not out looking for it, trying to figure out what applications we have that have that vulnerability, or looking for certain tools or writing scripts to go out and discover those things. We can go to our bill of materials. We know which applications, which software, which components in our environment potentially have that vulnerable piece of software. So what are the challenges? This sounds great. Alyssa, this is wonderful. Yeah, we can create these inventories. This would be a great thing. Well, anybody who's tried to create an asset inventory, you know how difficult that can be. So if we're trying to now do this with software, it's equally as difficult. We see some tools in the marketplace, they focus on license-based inventories. So this is great. Hey, if I bought a license of that software, I know that I have it, it's in my environment. Hey, if I signed a license agreement on an open source piece of software, I know that's now in my environment. So if I look at my licenses and I manage all that, I'm great, right? We already talked about the fact that there are certain packages out there that don't require specific license agreements. How do you identify those? Additionally, this license-based inventory doesn't get you past that first layer. It doesn't let you see what is in your dependency tree. What other software is there that package that you signed the license agreement for has now separately licensed themselves? So trying to leverage licensing as a method to inventory your entire software bill of materials is just not effective, because we can't walk through that dependency tree that way. We need tooling, we need the capability, we need the processes to look inside and understand that full directory of dependencies that exist within our application. It's also made more difficult when we start talking about third-party components or third-party software. You buy something off the shelf, there's no guarantee you're going to get anything in terms of visibility as to what open source or other third-party components may be a part of that software that you just purchased. So when a vulnerability comes up, something new is announced in the industry, it may not be obvious to you that that exists in your environment. And now you find yourself once again scrambling, trying to write those scripts, trying to use testing tools, trying to use other things to tell you, does that vulnerability exist somewhere in your environment? Where? How do I patch it? How do I fix it? This is complex. This is not how we run a business. And then finally, how do we format that SBOM for consumption? There are a lot of different ideas here. If I get a really cool graphical dashboard that shows me all these names of different packages and things, that's great. But how do I use that? When I'm talking millions of lines of code that exist across, in most financial services companies, potentially thousands of different applications, just simply giving me this dashboard doesn't really tell me a whole lot. I need something that I can leverage in a better way. So I'm going to shift gears for a moment now. A lot of us are seeing this motion in the industry, this motion that's causing us additional complexity around this. You might look at this idea of creating this inventory, this SBOM, and say, all right, that's great. I'll audit my software. I'll just do that. Well, we're moving more and more in this industry to this DevSecOps model, where we've got competing motions. We've got security trying to push left. Security has been trying to push left as long as I've been in this space. We've always talked about push left, push left, push left. We understand that pushing left means we can fix bugs. We can fix software vulnerabilities. We can fix our code cheaper and easier the sooner we identify those bugs in that development pipeline. So we've got that motion. But we talked about this idea of containers and infrastructure as code when we start getting into orchestration with things like Kubernetes. This is all stuff that's being defined in code, which means you now have developers pushing further right. The hands of developers are moving further and further into the deployment model, and they are now responsible for security further and further right in that pipeline. And then finally, because this stuff is going to code, because things are more and more code defined, they're not just bare metal servers sitting in a rack somewhere running operating systems that are out of the box, installed and ready to run. Our ops teams are pushing up the stack. They're having to understand things at application layers. They're having to understand things from code perspectives. And so these motions make it very difficult to determine how do we get there? How do we create this SBOM? Where is the right place to insert ourselves? How are we going to do this? And how are we going to do it in a way that we can adopt it across our organization? For anyone who's been through quality training, you might be familiar with Deming's principles. 14 of them. His 9th principle is the one that really speaks to what we're trying to do when we talk DevSecOps. It's this idea of breaking down barriers, breaking down the silos that exist between those various teams, those various disciplines, where we have developers pushing right, security pushing left, ops pushing up, business. I didn't even mention business pushing down, because they're becoming more and more involved in the daily life cycle of software development as they become more and more responsible for writing user stories and requirements and so forth. So the idea of breaking down the barriers between them is the foundation of DevOps, but it's also the foundation of how we can start to figure out where and how in the development pipeline, we're going to build out these SBOMs. So I know I need a software inventory. I need to understand what's in my software, whether it's software I'm building, whether it's software I'm purchasing. I need to inject myself here somewhere, and I need to be capturing that information, but where and when is the right time? How do I break down these barriers? How do I make sure that it's an adoptable practice? I need to think in terms of developer enablement. I need to think in terms of frictionless enablement. How do I make sure that the people in my organization who need to provide me with this information are going to do so? That the things that I'm asking them to do, they can adopt quickly and easily so that they will actually adopt them. If I introduce more friction into somebody's daily working environment, I can rest assured that the adoption of those practices that I've injected into their workflows is not going to be successful. They will circumvent it. They will not do it with quality. It will not give me the results I'm looking for. So as I think about it from an SBOM perspective, how do we get into the DevSecOps pipeline and make this work? Let's talk about the way that security traditionally functioned. When we talk about security, even years after DevOps was introduced to us, and we were in our security industry, we were talking all about how we were going to get involved in DevSecOps. We need to put the sec in DevOps. Yet every talk that you went to on this subject, every white paper you saw, still touted the same security approach. We're going to create quality gates that sit between our various phases of this development pipeline, and each one of those gates has to be passed before you can move to the next phase. It doesn't work. This is what breaks DevOps. This idea that we can insert security as a gate that sits between phases of this pipeline. And it doesn't have to be even DevOps. This could be an agile pipeline and you have the same issue. Each one of these gates takes time to execute, takes time to process, and causes a lengthy feedback loop that slows down development. The goals in development are the opposite. They do not want to be slowed down, and those goals come straight from the business. Speed to market is everything. Fixing vulnerabilities fast is everything. But if I have quality gates all the way along through my process that say, well, after you take those stories off the backlog and you build your sprint, well, now we need to do our threat modeling. And then after you commit your code, well, now we need to run this SaaS tool and this software composition analysis, this FCA tool. And then once you build it and as part of your, once you're done testing, well, then we want to hit it with a dynamic application security test and make sure that from the user perspective, it's secure. And then we'll deploy it, but then we need to penetration test that environment to make sure that those containers are secure. And any one of these can feed back and cause us to backtrack through this pipeline. This doesn't work. So as I look at this today and I say, I want to build an SBOM, and I want to do it in a way that my developers can be enabled. And I want to do it in a way that my security team has oversight. I want to do it in a way that my ops team isn't challenged with now a new set of requirements that they are responsible for. And I want my business to still be able to move quickly. I need to look at this and say, all right, where do I add this process? Where is it going to be most effective, but where is it most likely to be adopted? And that is by moving away from being a gate and injecting this idea of software composition analysis into your coding and your commit cycles. So literally getting to the point where those dependencies are introduced. Now, this sounds great. But again, what am I going to do? Ask all of my developers to sit here and document all their code? How well is that working for you today? Are you getting extensive documentation of all your code and it's accurate and covers everything. For most organizations, that's simply not the case. And as they're moving to DevOps and they're getting into this idea of CI/CD pipelines where we're continuously integrating and deploying new software changes, that becomes even less likely. And again, it breaks that model. And it becomes something that is onerous for your developers, and it becomes something that's not going to happen. So Alyssa, you're telling me this, that's great, but how do I move from this gate model then to something where my developers are able to give me this information, but I'm not making their lives more difficult? That's where frictionless enablement becomes crucial. And how do we enable developers? It's not by asking them to create documentation. This is how developers document when they're putting together a sprint. Is this what you want your SBOM to be built out of? This thing that's so critical to your security? No, this is not the way to go about it. This is not what's going to work for you. So we need to think about it differently. How do I get there? I can't create this requirement that, hey, when you commit your code, you also have to submit an SBOM. It just simply won't work. You won't get accurate results. Your developers are going to try to get through that as fast as they can. Sure, you can pull in project managers, you can pull in your business and analysts and such. Now you're talking about handoff from the source of the information to somebody else who now has to document that. These are all the things that have been fraught with difficulty in software development for years and years and years. We can't expect that it's suddenly going to work now because we have this critical thing we have to build that we're calling an SBOM. So instead, we need to meet the developers where they live. These are the technologies that developers are using today. I need to bring them processes. I need to bring them tooling that fits into the world that they already live in today. When we think about repositories, you see many of those up here today. They're checking their code into GitHub or into Bitbucket, or maybe you're using, GitLab. If you're building containers, is your code getting checked in? Do you have private repositories in Docker Hub? Imagine how effective you could be in building an SBOM if every time one of your developers or your infrastructure people or whomever checks in code to a repository, you could grab that information instantly and understand what dependencies were just introduced into your environment by that new code. This means your developers don't have to create something new. They can get that immediate feedback. What if we take it even a step further? I'm talking about repositories here. What if we build right into the IDE? What if we can build into the CI/CD pipeline tools that we're using in our DevOps pipelines? This is where we talk so much about automation in DevSecOps. This is why. This is where automation becomes crucial, because we're enabling the developers to do the security thing, to launch these security practices that we want them to, just by simply integrating it and taking the developer first in our approach to how we're going to institute these new security practices. So building your SBOM needs to be built in to that coding and committing cycle. And you do that effectively by enabling the developers to do it in the tooling that they already have today. So could you use GitHub Actions to pull some of that information? So each time something's committed, you can look at it and read its dependency tree. Could you plug into your Docker repositories? This is where tooling becomes crucial. But I also mentioned this problem of ingestion. And this comes into play. How am I going to build out this SBOM? What does an SBOM actually need to look like? Well, there are crucial things I need to take into consideration for that. And there's no one right answer here. Just like so many other security metrics and things, it really depends on your organization and how you want to consume it. But things you need to be aware of, first and foremost, that vendor management component. This cannot get lost. Do your contracts require your vendors to provide you with an SBOM? I know a lot of vendors today are going to tell you they simply don't have that capability. Well, it's going to take pressure from the industry, and in particular financial services, where every vendor wants to get to anyway. Every vendor out there is trying to find the way to build their involvement in financial services and to grow their investments here, because they know financial services is so far ahead as far as their security posture, as far as just maturity overall. We can leverage that to our advantage. Sure, maybe you go to them and you ask them for this specific contractual requirement today that says that they have to provide you with an SBOM, and they're going to tell you, no, we can't produce that today. So build it in for the future. Give them time, but give them that contractual motivation that they now have to supply you with that SBOM by a set date. Working with your vendor management teams to ensure that any third-party software you introduce has been reviewed for its own software bill of materials is crucial to building your own SBOM. The second piece of this then is making sure that you think about automation. And I talked about this with the CI/CD pipeline, with just any DevOps pipeline, or even an Agile pipeline. Enabling your developers by automating the creation of this. It needs to be something that is not your developers, it's not your project managers, it's not your business analysts, it's not your architects sitting down and writing out what packages that they're adding to the software. It's not having them dump the dependency file and show that in some other documentation, because you're not getting your indirect dependencies. You need to think about this in terms of an automation strategy. How do I automate the collection of this information so that it's updated real time and that I can monitor it and update it long term as the landscape changes? And as I said, you need to turn it into a life cycle. So what do I mean by a life cycle for this? It means you need to have that constant monitoring. As packages get updated within your code, you need to look and see, did that package change? Did it introduce new subdependencies? So we went from version 1.41 of this Lodash package up to, say, version 1.8. Well, what new dependencies did they introduce as part of that? And I need to be able to recognize that at the time I introduced that new code to my software, or I update a vendor's software. I get a new version from my vendor of that third-party component or that third-party application that we're using. How do I know? I need to make sure that there's a life cycle for getting the new SBOM and updating our own SBOM and then reviewing it. Because at the end of the day, we need to be doing auditing. We need to understand that our SBOM is accurate. So this is now that fun manual thing that I know we love having auditors move around in our environment and ask us all sorts of questions and do all sorts of things, but it's necessary. It's crucial in this case to take those spot checks, to look at your applications, to have somebody go through that SBOM and validate that all of the third-party components and other libraries and things that are being pulled in to that application are documented properly and being reflected appropriately within the SBOM, so that we know that our SBOM is trustworthy. Because what's going to happen is there's going to be another vulnerability that's going to show up. It's going to be in struts. It's going to be in jQuery. It's going to be in some open source module that we may not know where it exists in our environment. We need to go chase that down. Having that accurate SBOM is what's going to do it for us. And then finally, that all feeds into our automation and dashboarding. So I've automated this. I'm doing my continuous monitoring. I'm making sure this is all accurate. Now, how do I visualize this at an executive level? How do I visualize this at the director level? How do I make sure that all of that leadership chain that's involved in managing the risk for my organization, that we can very easily see not just the security implications of what it is, but the license implications as well, because all of this means risk to the business at the end of the day. So it's wonderful to have this SBOM. It's wonderful that we've got all this accurate data, but if we're not visualizing it and we're not providing that up through our executive levels of leadership and indeed, in many organizations, that's board level information these days. Boards of directors are increasingly wanting to understand some of these metrics from a security perspective because they're starting to understand what this means in terms of business risk and how that business risk picture affects their planning for the business over the coming years. So building your SBOM creates that visibility, dashboarding it, giving that ability for the highest levels of your leadership to really understand and make decisions and be empowered and informed to address the risks in an appropriate fashion for your organization. That's what software supply chain security is all about. That's how you get a handle on what's in your software. So with that, I want to say thank you. That's my presentation for you today. I hope you've been able to gain some insights into this. I certainly am happy to discuss further with you any of the information that I've talked about today. I know I saw a question already out there about the slides. The slides will be made available to you after this presentation. You have my information there. As always, feel free to reach out to me through social media. You have my email address, you have my Twitter handle there, my LinkedIn information. Always happy to connect and discuss any ideas you might have. If you have experiences of your own, I would love to hear about them as well. And I believe at this point, we're going to open up the floor for your questions, and I'll take some of those as well and see what I can do to answer any questions you have.
All right, thanks for that great presentation. We do have some questions ready for the Q&A. However, if anyone has a question for Alyssa, please enter it into the questions window now. Our first one asks, what role does business impact analysis play in the SBOM lifecycle?
So this is a good question because this could go in two directions. And honestly, it needs to be there needs to be a feedback cycle here. So business impact analysis certainly plays into our SBOM collection, just in terms of how are we going to manage that SBOM, or even as we're launching some of these, some of these initiatives. Of course, it's the age-old understanding which of those applications are going to be most crucial to us, what that impact is, and then understanding as we start to look at those various components that are a part of our SBOM, which ones have that greatest degree of involvement in our organization so we can start to prioritize. So if I know that, say, this vulnerable, this jQuery package exists in 5 of my most mission critical applications, that now feeds into my business impact analysis, because now I know if a vulnerability comes out in that particular version of that jQuery module, those are 5 business critical applications that are impacted. So you see where the SBOM can feed into the BIA, and you also see how the BIA can then feed back into the SBOM and how we construct that, how we focus on it, and so forth.
All right, thank you. Our next one says, if official container images have so many vulnerabilities, what is the best practice for ensuring our containers are secure?
Sure. So I touched on this a little bit already, but it's first and foremost, it's just understanding that official images aren't secure, which now you have that understanding. Second is what I alluded to before, and that's this idea of simply ensuring that you use a base image that has basically the least amount of libraries and other components in it that your application or your microservice is going to need to run. So it's kind of the age-old, sort of a case of what's old is new again, where we've talked since we had on-prem servers in a data center. It was always about how do we minimize the access rights, how do we minimize what software we're installing on these machines, it was all about minimizing, and it's still that way today when we think about containers. Picking that slim image, which is scaled down, doesn't have all the unnecessary libraries that you're not going to need. Finding that right image, or maybe even finding one that has slightly less, than what you need. Maybe it's missing a library or two. And then in your Docker file, you can run the commands to add in the additional libraries that you need when that container spins up. And now you can ensure that you're not only eliminating a lot of the vulnerabilities, because as I said earlier, we saw 90% could in some cases be eliminated just by changing that base image, but you're also gaining greater visibility into the contents of that container image that's ultimately being deployed in your environment.
All right, thank you. The next one asks, can limiting our dependencies to known good packages resolve some of the issues with vulnerabilities in those packages?
So this is a challenge that has come up quite a bit, and it's an idea that's been tossed around. I've heard a number of different people throw it out there, and unfortunately, first of all, it's not particularly realistic to think that you're going to be able to inventory and identify packages that meet every conceivable need that your developers are going to have, and that you're going to be able to build this standard list. That simply just, it isn't particularly realistic in the first place. But even if you did, it's the open source world and it's very dynamic. So what is a known good package today, next week may not be, because changes may have been introduced to it. Vulnerabilities may have been identified in it. And so even if you're using a known good package, that doesn't necessarily eliminate your vulnerabilities. And so that can be a massive challenge in the idea of trying to just limit what it is that we're going to use within our software. And so, no, I don't think that that's a viable option. And it's unfortunately something that's been commonly talked about. We think about how to blacklist or whitelist things. It's simply not realistic to think that we're going to do that. And then finally, the last piece of that is, how do you even really measure the security of a package? And this is a concept I could do a whole additional presentation just on this whole concept of what we call package health, which is looking at all the various metrics that are available to us in terms of looking at open source packages, and how do I use those metrics? Which ones do I use? What do they mean in relationship to each other in order to come up with some objective measure of package health? The industry hasn't tackled that problem yet. There's a lot of organizations, Snyk included, who are developing things around this and are making improvements. But even that question in of itself of how do I determine which packages I consider trustworthy is a very difficult answer to come to.
All right, well, that's all we have for today. Thank you so much, Alyssa, for your great presentation, and to Snyk for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.